The crucial first step, understanding exploratory data analysis or EDA. Exploratory data analysis, often called EDA, is a vital process in data science. It is the very first thing you do with any dataset. Think of it as becoming friends with your data. You want to learn its characteristics, you want to understand its story. EDA helps you uncover patterns, spot strange things, and check your assumptions. This early exploration guides your entire analysis. Without good EDA, you might miss important details. You could also draw wrong conclusions later on. It is truly a foundational step for any data project. The primary goal of EDA is not to build complex models immediately. Instead, it is about understanding the data's structure deeply. It involves looking at the data from many different angles. You will ask many questions. What are the main features in my data? How are these features distributed? Are there any relationships between different parts of the data? EDA uses simple tools like summaries and pictures to answer these. This process helps you build an intuition about your dataset. This intuition is very valuable for more advanced analysis later. Why is EDA so important? Imagine you are a detective arriving at a new crime scene. You would not immediately arrest someone. First, you would look around carefully. You would gather clues and examine evidence. EDA is like that initial investigation for data. It helps you find clues hidden within the numbers and text. These clues can point to interesting insights or potential problems. For example, you might find errors in data collection, or you might discover unexpected trends. This careful first look prevents future mistakes. Ultimately, EDA sets the stage for everything that follows in a data analysis workflow. It helps you to formulate interesting questions or hypotheses that can be tested with more formal statistical methods. It also informs how you might need to prepare or transform your data for modeling tasks. Skipping or rushing EDA can lead to wasted effort on complex analyses that are based on flawed or misunderstood data. Therefore, investing time in thorough EDA is always a wise decision for anyone working with data, ensuring a more robust and insightful outcome for your project. Gearing up, your Python toolkit for EDA. To start your EDA journey with Python, you need a few key tools. These tools are software libraries. They add powerful functions to Python for data work. The most important library is Pandas. Pandas is excellent for handling and analyzing structured data like tables. Another crucial library is NumPy. NumPy supports large, multidimensional arrays and matrices. It also has many mathematical functions. These two libraries form the backbone of most data analysis tasks in Python. They make complex operations much simpler to perform. For creating charts and graphs, you will use Matplotlib and Seaborn. Matplotlib is a fundamental plotting library. It gives you a lot of control over your visualizations. You can create many types of plots, from simple line charts to complex diagrams. Seaborn is built on top of Matplotlib. It provides a higher-level interface for drawing attractive and informative statistical graphics. Seaborn makes it easier to create common EDA plots like histograms, scatter plots, and box plots. These visual tools are essential for understanding data patterns. Installing these libraries is usually straightforward. If you use a Python distribution like Anaconda, these libraries often come pre-installed. If not, you can install them using pip, Python's package installer. For example, you would open your terminal or command prompt. Then you would type commands like, once installed, you need to import them into your Python script or Jupyter Notebook. This is done at the beginning of your code, for instance, and a Jupyter Notebook is a highly recommended environment for EDA. It allows you to write and run code in small blocks called cells. You can also include text, images, and equations alongside your code. This makes it easy to document your EDA process step by step. You can see the output of your code, including tables and plots, directly in the notebook. This interactive nature makes Jupyter Notebooks perfect for exploring data. You can try different things, see results immediately, and build your understanding iteratively. Sourcing and scrutinizing population data. Population data can be found from various reliable sources across the globe. International organizations like the United Nations, UN, and the World Bank compile and publish extensive demographic datasets. National statistics offices of individual countries are also primary sources for detailed population figures, often including census data. Academic institutions and research organizations sometimes provide specialized population datasets. When searching for data, it is important to consider the scope you need: global, regional, national, or even subnational levels. Always look for data that comes with good documentation about how it was collected. Let's imagine we found a population dataset. This dataset might be in a common format like a CSV, comma-separated values file. A typical population dataset could contain columns such as country, year, population underscore total, population underscore growth, underscore rate, and population underscore density, underscore per underscore skew underscore km. Each row in this dataset would represent a specific observation, perhaps for a particular country in a given year. Understanding the meaning of each column is critical. This is where metadata, or data about data, becomes incredibly helpful. Metadata explains units, definitions, and collection methods. Before diving into analysis, scrutinize the data's source and its metadata carefully. Ask questions like, who collected this data? When was it collected? What is the time period covered? Are there any known limitations or biases in the data? For population data, understanding how terms like population are defined is crucial. For example, does it include all residents or only citizens? Is it a mid-year estimate or an end-of-year figure? This careful preliminary review helps ensure you are using the data appropriately and are aware of its context. Working with population data also brings ethical considerations. Population data can sometimes contain sensitive information, or be used to make decisions that affect groups of people. It is important to be mindful of privacy if the data is very detailed. Always use aggregated and anonymized data for general analysis when possible. Ensure your analysis is fair and does not perpetuate harmful stereotypes or biases that might be subtly present in historical data. Responsible data handling is a key skill for any data analyst or scientist, especially when dealing with human-centered information like population statistics. Bringing data to life. Loading with pandas. Once you have your population dataset, likely a CSV file, the next step is to load it into your Python environment. The Pandas library is the perfect tool for this. Pandas provides a powerful data structure called a data frame. A data frame is like a table or a spreadsheet. It has rows and columns, and you can store different types of data in it, such as numbers, text, and dates. Loading data into a data frame makes it easy to view, manipulate, and analyze. This is a fundamental starting point for any data work in Python. To load a CSV file into a Pandas data frame, you use the function. This function is very versatile. In its simplest form, you just need to provide the path to your CSV file. For example, if your file is named and is in the same directory as your script, you would write. The variable now holds your population data as a data frame. Pandas can also read data from other formats like Excel files, SQL databases, and more. After loading the data, it is good practice to take an initial peek. Pandas offers several simple commands for this. The method shows you the first few rows of the data frame, usually 5 by default. This helps you quickly see the column names and some sample data. Similarly, shows the last few rows. To understand the size of your dataset, you can use the attribute. This will tell you the number of rows and columns. For instance, might return, meaning 100 rows and 5 columns. Another essential command for a first look is. This method provides a concise summary of the data frame. It shows the data type of each column, like integer, float, or object for text. It also tells you how many non-null values are present in each column. This is very useful for spotting columns that might have missing data. The output also gives an estimate of the memory usage. These initial commands are your first tools for getting acquainted with the dataset's basic structure and content. Section 5. First Impressions Initial Data Inspection Techniques. After loading your population data into a Pandas data frame, the next step is to inspect it more closely. Understanding the data types of each column is crucial. The attribute of a data frame shows you this information. For example, country might be an object, which usually means string. Year might be an int64, integer, and population could be int64 or float64, floating point number. Knowing the data types is important because it affects what operations you can perform on each column. Sometimes data might be loaded with an incorrect type, like numbers read as strings, which needs fixing. The method mentioned earlier already gives you a good overview, including data types and non-null counts. Pay close attention to the non-null counts. If a column has fewer non-null values than the total number of rows, it means there is missing data in that column. Identifying missing data early is a key part of EDA. Also, look at the memory usage reported by. For very large datasets, this can be an important consideration. Understanding these basic characteristics helps you plan your data cleaning and analysis steps more effectively. For columns that contain categorical data, like country in our population dataset, it is useful to see the unique values. The method can tell you how many distinct categories exist in a column. For example, would show the number of unique countries. To see the actual unique values and how often each appears, you can use. This is very helpful for understanding the distribution of categorical features. For instance, would list each country and the number of times it appears in the dataset. Getting a general feel for the scale and range of your numerical data is also important at this stage. While detailed statistics come later, even a quick scan of values from or which shows random rows can be informative. Are population numbers in the thousands, millions, or billions? Are growth rates small positive numbers, or do they vary widely? This initial sense check can help you spot obviously erroneous data points early on. For example, a negative population value would clearly be an error that needs investigation and correction. Example, Python code snippet for initial inspection, assuming is already loaded from the previous section print, and data types of each column, print df population types print and number of unique countries, if country in df underscore population dot columns dash print df population country, unique print and value counts for country column first 5, print df population country, value counts, head, else print column country not found in the data frame, print and show some random sample rows from the dataset, print df population dot sample 3, hash display 3 random rows. Section 6. The Cleanup Crew, Tackling Missing Data. Missing data is a common problem in real-world datasets, and population data is no exception. Values might be missing for various reasons. Data was not collected, it was lost, or it was not applicable for a particular record. Missing data can cause issues for many analytical techniques, and can bias your results if not handled properly. Therefore, a crucial part of EDA and data pre-processing is to identify and address these missing values. Ignoring them can lead to inaccurate conclusions or errors when running your analysis code. The first step is to find out where the missing data is. Pandas provides easy ways to do this. The method returns a data frame of the same shape as the original but with Boolean values where data is missing and otherwise. Chaining this with gives you a count of missing values for each column. This summary quickly highlights which columns have missing data and how much. Visualizing missing data patterns can also be helpful for more complex datasets. Once you have identified missing values, you need to decide how to handle them. One common strategy is to remove rows or columns that contain missing data. If only a very small percentage of rows have missing values in a critical column, you might choose to drop those rows using. If an entire column has mostly missing values and is not essential for your analysis, you might drop the whole column using. However, be cautious when dropping data, as you might lose valuable information. Another approach is imputation, which means filling in the missing values. For numerical data, common imputation techniques include replacing missing values with the mean, median, or mode of the column. The median is often preferred if the data has outliers, as it is less sensitive to extreme values than the mean. For categorical data, you might impute with the mode or a special category like unknown. The choice of imputation strategy depends on the nature of the data and the specific context of your analysis. For example, would fill missing growth rates with the median. Section 7. Refining your data duplicates and basic outlier awareness. Beyond missing values, another common data quality issue is the presence of duplicate records. Duplicate rows can occur due to data entry errors, issues during data merging, or problems with data collection systems. These duplicates can skew your analysis, leading to overestimated counts or inflated statistical measures. For instance, if a country's population data for a specific year is listed twice, any calculation of total or average population would be incorrect. Therefore, identifying and removing duplicate entries is an important step in the data cleaning process. Pandas makes it easy to find duplicate rows. The method returns a Boolean series indicating whether each row is a duplicate of a previous row. By default, it marks all occurrences of a duplicate except the first one as. You can use to quickly get a count of these duplicate rows. To see the actual duplicate rows, you can filter the data frame. It is often wise to inspect these duplicates before removing them to understand why they occurred if possible. Once you have confirmed that certain rows are indeed unwanted duplicates, you can remove them using the method. This method returns a new data frame with the duplicate rows removed. By default, it keeps the first occurrence of a duplicated row and removes the subsequent ones. You can control which duplicate to keep using the parameter, like or to drop all duplicates. For example, would create a new data frame without the duplicates. It is often good practice to assign this to a new variable or use carefully. While a full discussion of outlier detection is beyond basic EDA, it is good to be aware of them. Outliers are data points that are significantly different from other observations. They can be genuine extreme values or errors. Simple ways to get an initial sense of potential outliers include examining the minimum and maximum values from descriptive statistics or using box plots. For example, if the maximum population growth rate is extremely high compared to other values, it might warrant further investigation. Recognizing potential outliers early can guide more focused checks. Section 8. Numbers that narrate unveiling descriptive statistics. After cleaning your data by handling missing values and duplicates, you can start to summarize its main features using descriptive statistics. These are numerical measures that provide a quantitative overview of your dataset. They help you understand the central tendency, spread, and shape of your data's distribution. For numerical columns in your population dataset, like population_total, population_growth_rate, and population_density_per_skew_chem, descriptive statistics offer valuable initial insights. These numbers begin to tell the story hidden within your data. Measures of central tendency describe the center or typical value of a dataset. The most common measures are the mean, median, and mode. The mean is calculated by summing all values and dividing by the count. The median is the value that separates the higher half from the lower half of the data. The mode is the value that appears most often. For population figures, the mean and median can give you an idea of a typical population size or growth rate, though these can be influenced by very large or small countries. Measures of dispersion, or spread, describe how varied the data points are. Common measures include the standard deviation, variance, minimum, maximum, and range. The standard deviation tells you how much, on average, individual data points differ from the mean. A low standard deviation indicates that data points tend to be close to the mean, while a high standard deviation indicates that data points are spread out over a wider range of values. The range gives a simple idea of the spread. These measures help understand the diversity in population characteristics. Pandas provides a very convenient method called that calculates several common descriptive statistics for all numerical columns in a data frame. This includes count, mean, standard deviation, minimum, maximum, and quartile values. The 50th percentile is the median. For example, we'll output a table summarizing these statistics for population, year, growth_rate, and density. Carefully examining this output is a key EDA step. It can reveal skewed distributions or highlight potential outliers if min or max values are extreme. Section 9. Visual victories, charting population insights with Python. While descriptive statistics give you numerical summaries, visualizations help you see patterns in the data. Graphs and charts can reveal trends, distributions, and relationships that numbers alone might not make obvious. Python libraries like Matplotlib and Seaborn are excellent for creating a wide range of visualizations during EDA. For population data, we can create plots to understand how population figures are distributed, or how different variables relate to each other. Visual exploration is a powerful way to gain deeper insights quickly. Histograms are great for understanding the distribution of a single numerical variable. For example, you can create a histogram of the population column to see how many countries fall into different population size brackets. This can show if most countries have small populations, large populations, or if the distribution is more even. Seaborns or Matplotlibs can be used for this. Would create a histogram with 10 bins, helping to visualize the frequency distribution of populations. Bar charts are useful for comparing categorical data or showing counts. If your dataset included a continent column, you could use a bar chart to show the average population per continent. Or you could plot the population of a few specific countries over several years. If you have time series data, like population for one country over many years, line plots are very effective. A line plot of verses would clearly show India's population trend over time. This helps to see growth patterns visually. Scatter plots are used to explore the relationship between two numerical variables. For instance, you could create a scatter plot of population underscore density versus population underscore growth underscore rate. This might reveal if densely populated countries tend to have higher or lower growth rates, would generate such a plot. Looking for patterns, clusters, or correlations in scatter plots is a key part of EDA. These visual tools, combined with statistical summaries, provide a comprehensive understanding of your population data, paving the way for more advanced analysis or modeling. EDA is truly an iterative cycle of summarizing, visualizing, and questioning your data.